Hello? Hello? Do you hear me? Uh, those who belong to the jury members are welcome to sit in front. So, Wilfried, Frieder, could you please come in front? Because then there will be the question and answer session, and it's good that all the juries is here. It's more convenient. And yeah, Florian will join online. So maybe we could start calling Florian, who is also part of the jury. You can also dial in the mentors that we had in Basel, because at the end they are going to talk about the way they had implemented Balois challenge. So you tell me when I can start, okay? Am I live already? Now, yes? Okay, welcome everyone. It's been less than 48 hours. I saw a lot of you with a lot of energy. It's been great experience. I loved it. I really loved it. Everyone loved it. I had a talk with the mentors, with the coaches. We were going around, giving you input. You showed a lot of commitment. You did a great job. So now this is your time. You're going to make history today. So we wish you best of luck to you. And you had shown a lot of learnings. We are going to talk about it later. But yeah, now I just give the stage to the first team. So the first team's name is Taste, that comes from the Nunli challenge provider. Rohit was the one who pitched the challenge, and now I would like to welcome the team members. We have Ashan Mansour, Michael Abrion Arias, Bollazzi Leonardo, Dattilo Danilo, Abdullah Nakvi, Dilani Marco, and Bagai Sara. And the presenter will be Abdullah Nakvi. So Abdullah, you're welcome to come here. I'll give you the pointer. And also, I think this on is better. That's the microphone. Should we put it on full screen? Yes. Full screen. So you have 10 minutes and then 5 minutes question and answer. Brilliant. Perfect. Good luck.
We're good? We're all right? Perfect.
Sorry.
No, go ahead. So, how we all settled in then? Perfect. Ladies and gentlemen, good afternoon. Welcome, Madame and Monsieur. Thank you for attending the MAKEathon of 2021. Our presentation, we would like to provide a few data plus an evaluation of our app, what we've done in these few days. So let's start. First of all, what I would like to present is something about food. As you know, food has been a fascination for mankind through the ages, surpassing cultures, religion, and nationalities. From creating our own recipes to utilizing technology to have the choice made for us. What we will present today is about the aspect of machine learning, how we've implemented this together with the human behavior. So back in the day, of course, everyone had their own choices of eating food and the choices of how they would like to consume. But now we would like to have a really interesting tweak to it, and the tweak is machine learning. So if I move to the first slide, as you can see here, we have 3 choices of foods. The first choice a pizza, the second choice a burger, and the third choice a sandwich. So our main goal from combining these two aspects, the machine learning and the human behavior, is basically to make sure we do not land up in one choice, which is just a generalization. So the point, the goal of what we would try to achieve is basically have a few choices, and those customized choices would basically land us to something which would be preferable for us and not something randomized. So for example, if you're choosing a pizza, it should not be that you end up having a pizza at the same time. That defeats the whole purpose of machine learning. So our point was to basically optimize each and every stage to a fact that the person, the end user, is happy with the result, and not just happy so he can move forward and utilize those services. So basically, if you see here the concept, we basically started doing the concept of what we can actually do, what should be the approach. So, so we had to basically not think of us as the innovators, but at the same, we had to actually look at how would the end user basically look at this whole problem and issue, and how would he be able to tackle it. So as you can see here, we've taken some examples of some online services like Just Eat. I mean, of course, everyone's aware of that. Just Eat, midnight deliveries and stuff. So the aspects we wanted to highlight here is, for example, what is the main things a person sees, the end user, when he's ordering something? So the first thing he sees is, okay, what's the name of the brand? What's the provider of the service? Second of all, what are the ratings? What is the price? So this is something, I mean, from these two choices, it might look really easy for you. Of course, if some people like pizza, they're like, oh, this pizza looks much nicer than this one, of course, and it's an easy choice. But other aspects have to be taken into consideration. So we started digging up. We started researching, and people, of course, from our different backgrounds, some being from a business perspective, others being from an IT perspective. And I am happy to say, at 5 o'clock tomorrow evening, yesterday evening, sorry, in Urdu it's like tomorrow and yesterday the same words, please mind me. So by yesterday evening at 7 o'clock, after doing all of our research, doing all the painstaking ideas we had on the table, we hit rock bottom. We didn't have anything. So we actually saw by doing all of our researches, we would actually get somewhere, but we did not get anywhere. So we had to scratch all the ideas, have a different point of view of how we should approach it. And then we came up with the following steps. So the data, what we've collected now, which Rohit would enlighten you later.
Should I explain it from here?
You can have, yeah, please go ahead. Yeah.
So basically we fell down, and then the only respite we have is in our teachers. So we got them all together in a room, and then we tried to rescue ourselves. And so this was step 0. So we brought this data, which was basically a rating as well as we call it engagement. So if you see 125 comments. So the idea was to use these two parameters and try to do a recommendation for a user. We were educated in this session in the evening that you need the user dimension as well to make a rounded recommendation. So we moved here. So we found that there are also comments from users. And what we assumed at that point is that if user has commented on any of the recipes, then most likely they've liked the recipe for some reason. And then we created a 2-dimensional matrix from the recipe as well as the user ID of the users who liked the recipe. And then we found that there is more ambition. The face is very nice. So, but we have more, and this is for the future. So we did this part by a 2x2 matrix using using recipe and user comments. So this is the matrix, how it looks like. So user, recipes, and we decided to use KNN. And yeah, we were told that if you're using KNN, use k-means because that's supported by the platform. So we had to shift. The outcome was not satisfying. So we tried to change the value of k to see where the answer lies for us. So we had around 579 unique users. So we thought that we could in an extreme possible case, we could have 579 clusters for some reason. So we tested the range of K from 2 to 579 in different capacities, but we did not see much of a change. We are attributing this that it could be related to the way we collected the data from the website, and it might not have been very, very accurate. So at least we have this one learning for us. So this is how it went for us. Questions?
Great. Any question from our jury? Who would like to start? Frieder? The microphone. Wait. We need a microphone. Do we have... No, you can... We have enough microphones. Come on. We have enough microphones.
Yeah, go on.
I was just wondering the k-means. How do you do it? So you have a new user, and then you check which cluster this user belongs to, and you show the user all the recipes of people or that people in this cluster commented on. Is that what you did?
So that was the logical approach that we took. So we had a 2x2 matrix, as we discussed. So we had the user, and then we had a list of recipes in the column, and then we basically identified which user liked which recipe, and 0 for not liking if we didn't interact with a particular recipe, and then we repeated the same process for all the users. So we created this 2-dimensional matrix. And
you clustered the users, right?
Yes,
not
yes.
the recipe.
Users on the recipe selection, correct?
Yeah. Okay. Thanks.
That's the first time I got the question. Tough question.
Just a follow-up of this. So I still did not get it. This is the onboarding process. So the person selects these 3 choices, and then what do you look for? You look for people who voted on this recipe. Did I get it?
Okay. So there are 2 parts to this specific question. So one part is when the new user is coming in, right? And typically, like a KNN, I want the user to choose something, and then I want to take his recipe selection and try to map it to the recipe selection of an existing user and find the nearest user, and then use that user's journey to recommend this user. So you are correct. That's what the idea was. The graph that you saw was the outcome of the data that we had, because we could not form the clusters. We could not form those clusters.
And what does near mean when you say the nearest?
Okay, so
how do you measure the near?
Okay, so I will answer it in a very business sense as an end user. So near for me, so for example, let's say there are 5 users and there are 700 recipes. And these 5 users have interacted with, let's say, 200 recipes. And all these 5 users have not liked the same recipes. Then they are 5 distinct clusters for us. And any new user that comes in and chooses a particular recipe, the near means which existing user has already had those 3 recipes chosen. And since we know that these 5 are distinct and they've not chosen the same recipe, so obviously this new user will fall into one of those categories. That is near.
Okay, thank you.
Thank you for the easy questions.
Did you think about how to combine that with knowledge engineering? Because from the data, it seems that you don't get some good results. How could you add knowledge engineer or add knowledge to improve that?
Yeah, so we discussed this option. Actually, we initially discussed the knowledge option. So if we can go back to that slide, go back. So the idea was to use neural language processing for this text that is written in the comments, and then use sentiment analysis to kind of try to rate how the users felt about the recipe. But I didn't want to break my team, so we stayed away from NLP, but this is obviously something to explore for us further. Because we've exploited one option. We know that this just comment ID and recipe mapping doesn't work. Not at least in what we tried.
Did you try to cluster both domains, the user domain, maybe also add some clusters only in the users and maybe also in the recipes?
Yep. So for recipes, we do it only based on ingredients. So you can make independent clusters there. For users, unfortunately, there is no realistic data. At least, I mean, I thought this was quite realistic. But even with the result, I think this is also not realistic. And there is evidence for this. So for example, we went and checked this because when we didn't see the results we wanted, we looked at, so for example, for this recipe, there are 125 comments, right? You see this. But if you go to comments, you never find 125 comments. You always find 10 or 15 comments. So there is a gap.
Okay, yeah, thanks.
Thank you.
Could we have time for another
That's
question?
cheating. I mean, you were with us.
Yeah, just
Only a challenging question now is allowed.
yeah, might be a little bit challenging, but considering and I would potentially this would be one part of the question. So considering the limitations of the data you have, which you just mentioned them, right? And the limitations of the approach, the time you had, the algorithms, and all the limitations that you have found during this, right? If you were to design something like this from scratch, do you have some ideas on, for instance, how to improve the data and how this whole thing could work better?
Okay, so that's actually a very good question. So because this is already out there as a product, and initially I thought that this could work, but unfortunately, initially I did not spend so much time on social data gathering. So we have around 20 people, physical, regular, normal people, who are on board this platform, who are actually contributing to build, for us to build this model. So we do recipe recommendation based on ingredients and Euclidean distances. Machine learning guy can explain it better. But so this is the mechanism that we are using. It is a manual mechanism. So I talk to those users and they tell me that, okay, this is, I mean, I liked this recipe, I didn't like it. And then we take the feedback back into the system, right? That's one way. The second way that we are planning to explore now is that we are also going to bring in the third aspect, which is the future, right? And then ignore the comments. Ignore the comments and then see what the user likes. For example, meine Ernährungsweise, and then try to see what they liked. So that way, maybe we can create a cluster here in terms of what the user choices are and what they've actually liked, or commented. So that way, like, there are 2-3 approaches that we can think of.
Yep. Thank you.
Thanks.
Thank you.
Thank you.
Yeah, you can leave it here, down. Thank you. Good. So now we will also talk about another recommendation systems, this time from big data. So I would like to welcome on stage the team, the scalers. So members are Vittorio Rinaldi, Samin Zibi, Yaman Ibrahim, Etienne Fry, Richard Neff, Thibault Gegno. Diego Fanesi was the challenge provider, and the presenter is going to be Thibault. Thibault, do we have Thibault here? Yes. Excellent. Your presentation? Where is your presentation? This one, ah, okay, perfect. True. All right. Good. Good luck. 10 minutes and then 5 minutes Q&A.
Do we have a click pointer?
Yeah.
Perfect. So Ladies and gentlemen, welcome to our presentation, Team Databricks. Our challenge was real-time personalized product recommendation. You may know this from Amazon or from Digitech, Galaxus. When you go to their website, usually you have recommendations for you tab there. In this example, we have them even split by categories. So what you can guess maybe from these images is that it's maybe a woman because she has in beauty and personal care some lipstick, and in the home and kitchen category something else. And to achieve this, we have a big data problem, because in our data set we had 43 million customers and 15 million products. So I don't know, we had like at least 5 minutes to calculate this number here on the top down right, because we weren't even sure. So this is already the start of big data problems. You really need to know your math. So to solve this problem, we needed to scale. And fortunately, we had a Databricks platform, which has an optimized algorithm for that. And we used a collaborative filtering algorithm. What's collaborative filtering? So just that you understand the basic idea. So if I want to buy a coffee machine here on the left, then we search for people that have also bought coffee machines. And then we see or look what they also bought. So in this case, coffee beans. And then we recommend you who wants to buy a coffee machine, also coffee beans. Because we think that similar users also like similar things. So that's how the collaborative comes into play here, because the different users collaborate together to help us make better recommendations. So from a math perspective, you see the collaborative filtering using alternating least squares. You don't need to understand this. In the end, in each framework, you just need to make your ALS models and configure your parameters. But in the end, we did it and used a prototype with Databricks. Unfortunately, we couldn't use our original model with the 43 million because we only wanted to create a table, and our single node cluster already broke down to create this single table. So unfortunately, we couldn't do that. So we had to use another data set, which had only, I think, 5 million entries and 5 million products, so a little bit smaller, but still we made it and could implement this alternating least squares algorithm and had a test score here from 81%, which was nice. I mean, who has already trained 10 million data sets? I don't know if you've ever done this as a student, so this was a nice experience to be able to do that. I definitely think you won't be able to do this on this machine. Won't probably fit into the memory here. But this still doesn't solve the real problem, because we want to predict or recommend stuff in real time. Why is that? The reason is because shopping is mission-centric. What does that mean? Mission-centric means that yesterday I wanted to buy a coffee machine, but today I'm looking for a new computer on Galaxus or Digitech. So any recommendation for coffee machines are not really relevant to me. So when I click on a new computer, I want to get recommendations for this computer really fast. At best, immediately, because I'm mission specific. I have a mission to buy a computer now and not coffee machines. So to make this prediction in real time, that's a real challenge, because we still have this 34 million times 15 million matrix, which we can't calculate in milliseconds so that we can serve it over the request and answer your question. So unfortunately, even Databricks cannot help us here. So we need some tricks and some clever ideas. So we were thinking, basically what we want to do is, this matrix that we want to calculate, we need to reduce that matrix. And we need to reduce it to a small enough matrix that we can calculate in milliseconds. So how can you do that? Either we reduce the rows, so customers, or we reduce the products, or reduce both. So our idea was to find a pattern from customers that are similar. For example, here we have the customer, And on top, he buys a coffee, C1, and he chooses the sustainable one. Then he buys a shampoo, and he again chooses the sustainable one. Same for notebooks. And now we say, okay, yeah, when he wants to buy a t-shirt, he probably also wants to buy a sustainable t-shirt. And if we do that, we make a cluster for a sustainable customer, which reduces our matrix down to a matrix that we think is small enough and that we can calculate on the fly in this milliseconds. Unfortunately, as the platform was not able to handle our code, or we needed a much bigger cluster to solve that issue in such a short time on this hackathon. We couldn't test this idea, but we still think that it could work. And of course, this idea can be further generalized. I mean, you can use rules for the sustainability pattern and save it on a relationship graph. For example, one rule would be you cluster people according to price. According to the history, you know people that can afford more expensive goods, so the price range is bigger, and you know that there are people who always want to buy the cheapest thing. So you can cluster to, let's say, greedy people. I don't know, it's a bit negative, but that's what I call them now. And probably another important thing is demographics. So if you have Chinese or Asian people who probably don't really like milk, you don't suggest any product containing milk to them. And these rules, of course, can be changed. They can be adapted over time, and also lead to a smaller matrix. Exactly. And with this smaller matrix, we can then do real-time recommendations. That's it.
Thank you, Thibaut. Keep the microphone for the questions. Who would like to start? And then Frieder again. Yeah.
I was wondering, you said you want to make the matrix smaller. Is it just because you can better handle it and be faster? Or is it also going to improve the results because it's less sparse? Maybe you have less of a cold start problem or something like that? Is it going to improve the results as well? What's your opinion?
It's not going to improve the results because think of this: if you can query the whole matrix, you will find like the soulmate of yours, which really likes the same stuff. And if you cluster it, you will only find the average of the cluster, but this may not be like the similarity that you were looking for, but it's still good enough to compensate on this real-time issue that we have, that you want to converge as quickly as possible to this new product. It doesn't need to be the perfect product to get you onto the right side, but just a good enough. So it's more like speed over accuracy thing that you want to achieve. So I think the predictions will get a bit worse.
Okay, thanks.
You mentioned you will cluster maybe according to sustainability of products. How do you get this information, or how do you handle it if you don't have sustainability information about all your products?
We have a metadata set for the products where we have categories. So we can do a mapping from user to product to category. And then we have sustainability products, the category.
And how do you compare sustainability of a computer or sustainability of perfume or what else?
How do you compare this maybe in the metadata that we have eco-friendly strings in there? Yeah, exactly. So in this metadata, you also may have this string we didn't check for the sustainability example now, that we have this, but you have very narrow categories and other attributes. But yeah, this whole knowledge engineering, I would call it, or this relationship graph needs to be designed, and is of course another engineering work that is not easy.
Yeah, maybe also a follow-up question. You mentioned that the rules might change over time.
Yeah.
How would you adapt that over time?
For the rules, I mean, we were the ones defining the rules. That we want to say that we have a demographic rule that we implement, so we can change the rule.
Oh, okay. So just manually, always, if you realize something is different now,
Exactly,
then
yeah.
you change.
Yeah.
Yeah. Okay. Yeah. Thanks.
Any further question? I think we have time for another one.
Okay, maybe I have one question about the project you got running. You said you reduced the dimensions from like 80 million down to, I can't remember the exact numbers, a huge table down to a smaller table. How did you select the down selection? So did you select just based on one category so that you could still interpret the results, or is it just a random sampling, down sampling everything?
No, that's not what we did. The thing that we ran on, there we didn't do any down sampling. That was the full data set. That was a completely different data set that was just smaller. And there we did the whole thing, yeah. That was just to show that actually, I mean, the ALS prediction, that's what's already done today. That's what you run once a day. Probably takes, I don't know, if you don't scale with Databricks, it may take 7 hours, 8 hours. But if you have a good scaling ability, then it may take 30 minutes. And then you save this. And then you just to make these recommendations. And we first wanted to actually check these and make this work, because before you go real time, yeah, you want to have something that works to like fall back on. If your real time recommendation anyway fails due to network requests, then you need to recommend something. You don't want to have just a placeholder there. So then you need to fall back to the batch size ALS. So we first implemented that. Couldn't do it on our dataset because it was too big with 43 million. So we had to take another subset from another domain. It was movies and ratings, which was 10 million, and 10 million worked on our cluster with 4 CPUs and 14 gigabits of RAM. And unfortunately, due to restrictions, we couldn't use a better cluster.
Thanks. Maybe a question from my side. How do you see the next steps now, in case you would be a team and you have to just bring on this challenge till you accomplish some concrete goals?
Yeah, I mean, now that we know, first of all, probably we would just, if we have the money, we would just take, I don't know, 50 course cluster, try the same thing out on the real data set, see what kind of accuracy we get so that we know we have a stable baseline, so that we have the same as Digitech and Alibaba already has. And then we would try to test one of these clusterings and see if it works. And then, then the experimentation and parts begin. But we also looked at another machine learning approach, which is another algorithm that does not depend on the whole users, which is like cutting edge. But unfortunately, our data science knowledge is not good enough to implement this right now on the fly. But maybe we would like consult an expert and then see if that will work out.
Cool. Maybe we keep it for the next MAKEathon. By next year, I'm sure that there will be. This is not. Yeah. Sure.
Pretty much very similar to the question I did to the previous team. So if you looking at all the limitations you had, not the cluster one, because that's very easy to overcome, but talking about the data, right, the nature of the data, if you were to given the choice to decide what type of additional data you can collect, would this change your approach? How would you think? Would you have presented better ideas with potentially improving the data?
So if I understand your question correctly, you ask that if we had other metadata or other attributes, what we would have done differently. Is that correct?
Yeah, so essentially what is more likely, what additional data you would have liked to collect, and how would you have used this?
Yeah, I think not only ratings are interesting, but only also interactions with certain products or something we maybe could collaborate with Noonly. Comments, reviews of products are also an important feature vector, or could be. Or also just like how long you stay on a page for this product, how many like this product. Yeah, and clicks may also be a nice metadata that may be important. So I think in the end you need a whole package, and when you make to combine this into one with the clicks, links and stuff, then you have a really good solution. Of course, because it's also pretty hard to do, because you have to combine everything, yeah.
Okay, thank you.
Thank you. So thanks once again, and great job. Thank you, Thibaut. Do you miss anything? Yeah, no problem. Chat. So great. Now it's the turn of the Dreamers. Beautiful name. So the Dreamers are Remo Ugentobler, Sangai Yutenlama, Yasmi Rdina, Leon Lutli, Nawel Ozan. The topic is autism in children. That was pitched by Gurmit and Ann. And we have several presenters this time: Remo, Sangai, Yasmin, Leon, and Nawel. Who would like to start? Yeah. So the pointer and the microphone. Yeah, I think it should be already on.
Okay. Yeah.
Yeah.
Okay. Good afternoon.
Slides are arriving.
All right. Perfect.
Here.
So we've chosen the name Dreamers because we've worked with a data set called Dream. And we've had a very exciting journey in the last 2 days with Anne and Gamit, where we learned a lot about autism. So let's dive into it. What is autism? Autism is actually a spectrum on various symptoms. So it could be that there are a lot of challenges with social skills and speech and also nonverbal communication. And as a child, it is often the case that they cannot make friends in kindergarten or in school, that the behavior is like they're feeling often very angry or anxious and need much attention from their parents. So it is a long journey to the diagnosis, a long and complex way, like for getting diagnosed, you have to have a lot of interviews with the parents, with the teachers. You have to have an assessment that is called ADAS assessment, where you get a certain score and then finally get your diagnosis. And at the diagnosis, you're often getting stigmatized, so parents are getting blamed for the behavior of their children. And it is also very often ignored by the social environment. So we have looked at the stage after diagnosis because there is a poor access to a standard of care, especially when you want to receive an early treatment. So there has also been, it is important to mention the lack of affordability because the costs for an early treatment is up to 150,000 francs, which is most often not covered by the insurance. So the greatest and most important unmet need of the patients is the lack of self-advocacy, as the children are dependent on others, they cannot help themselves. So what is the DREAM project about? Well, It stands for Development of Robot-Enhanced Therapy for Children with Autism Spectrum Disorders. And we've had 61 children that participated, and it was a two-arm study. One arm was done by a robot, actually, and the other one by a person, a standard, SHT means standard human treatment. So why have they looked at this? There are not so many therapists that could ensure a treatment for every child that would actually need one. So that is why a robot could be a plausible solution for that problem. And there are several tasks. So we have the turn taking, which means that a child could would need to build something or to have a conversation with the therapist at a very complex stage. Then we have the imitation, which means mirroring, and we have the joint attention, which mostly involves skills like looking and being focused on the opposite. So what was our challenge about and the data set? We had data which contained age and gender. So the children were 3 to 6 years old, and also the clinical severity. We have to say we had the basic assessment, the scores of the basic assessment, and then we also had the level of complexity related to the tasks they had to do. And also if the session had been done by a robot or by a therapist. Then we had digital biomarkers. So each digital biomarker was represented by a vector. That could be the skeletal movement of the upper body. And then we had the head orientation, so you could see the head movement and the eye gaze. For the eye gaze, we have to say that the tool, the kinetic camera that had been used was not delivering very precise results, meaning we got the direction into which the child looked, but you could not analyze whether the child was looking into the eyes of the robot. So I think that is important to mention. Then we had the therapy tasks, as I already mentioned. The imitation, joint attention, and turn taking had different stages of levels representing the complexity. And now our focus was the feasibility. We wanted to find out whether we could find patterns associated to the skills of the children, using them for AI. So now we'll hand over.
So the data we received was from this project called DREAM, and it was quite a bit challenging because the data set is not actually complete because the study has not yet been published. So we don't actually have ground truth, so we had to create that. And we did that based on the complexity of the task that the child did. So the data we received was anonymous data. We had no medical data about the children. The head gaze, the eye gaze, and body movement, those are vectors which were in the data set, and the difficulty of the task that the child was doing. Like I said, the negative is that, well, it's not a complete data set. In order to make it a little bit easier for us, we decided to focus just on the task joint attention. because otherwise it will be quite complex to see if there's a correlation between the movement of the child during the time the child is doing the task and the improvement he does over the therapy session. This is how the dataset looks. Each file represents a session, and during these sessions, the measurements are done at 25 frames per second, meaning that we also had to compare that to minutes because we actually didn't know how much the session, how long the session was. And then we decided to convert that to a CSV, and maybe Leon can tell you more about that.
Yes, as you have seen, all starts with raw data, as you know. And here you see 7 segments of the data. Each segment exposes how the patient was looking the most. For example, the patient 1 was looking more to the left or more to the right side. And after that, we use this in Jupyter with Python and transform the data for preparing for the machine learning. And I think it was the most difficult part of it to analyze it, how we can transform the data corresponding to the machine learning algorithm. And the output was a CSV file, which was then uploaded to the machine learning tool.
Right. So the field, although the column passed, that was basically to check if the child had successfully completed task or not. And this is something we actually had to calculate based on the session and okay, I have to maybe explain that each child begins with the most simple task, and then they try to do this task as many times as it takes for them, and that can maybe be 2 sessions, 3 sessions, 4 sessions, and as soon as they get it, they get a more complex task. And we decided that, well, if complexity is 1, and afterwards, if the complexity increases of the task, then the child has successfully passed the task. We then used KNIME to train a model and basically represent the data on a decision tree. And what we can see is basically that the children who look at the center or look at the robot, they are more likely to pass. And based on the duration, the shorter the duration is, and the longer they can look at the center, when that basically means they pass the task. To the limitations.
Yeah, the limitations, well, we had missing the coordinates of the targeted object, so we did not know the coordinates of the robot. So you could actually not at first sight see if the child was looking at the robot at that moment. Then also, as I already mentioned, the lack of precision of the eye tracking tool, that was also a point. And it was a very small number of participants. So at first we had the idea to compare childs of different age, like let's have a group of 3-year-olds and 6-year-olds that have the same severity of the disease, but this was not possible because it was a too small number, and it would not have been a meaningful conclusion. Then, as I already mentioned in the beginning, it's a spectrum. So there is a various amount of possible manifestations of ASD. And finally, to mention that we did not have the final ADAS score, meaning we have the initial scores and we also had the baseline, but we did not see the final evaluation because the clinical results were not published by now. All right.
Now, I would like to talk about the general lack of trust and transparency today with biomarkers. We have created 3 circles. In the first one, you can see the data which is shared with the technician. And in the second one, it's shared with the family and the public. Now, the orange one is a big issue today, and there is currently no solution. So all those points are social questions which should be answered by all of us. Oh, sorry.
So here comes the summary. Relevant to the selected challenge, yes, we used digital biomarkers. And is it innovative? Yes, we used machine learning tool decision trees to analyze the data. And baseline, its accurate was like 60.5%, as you can see here. And with ML, it improved like 69%. And make combination meaningfully applied. We wanted to help to the children with autism at really early age and improve their chance of life. So finally, it's like thank you to everyone. Thank you.
Thank you very much. Maybe I start with a question this time. Very simple question. You have the talk about passing or failing. Was this determined by a rule of thumb, or there was some domain expertise?
So basically, usually that score would be defined by the ADOS score, but that was the part that was missing from the data set. And the child always starts with a very simple task, complexity 1, and then if they don't pass, then they continue with this complexity. And if they pass, they go to the next complexity. So our assumption is that, well, if they go to the next complexity level, well, they pass the task. That was.
Yeah, perfect. Thank you. Any other question?
You said in the beginning that you had you were randomly assigned a robot or a human to run a session. Did you have data from both the robot and human sessions?
Yeah, we have both the data from robot and the human, but the challenge is actually that the coordinates for the human or the robot were not recorded. So it was kind of hard to actually make an accurate assumption. And what we did is we defined basically ranges. That was the ranges that you saw in the presentation slide. I don't know if maybe we can go back.
Mm-hmm.
These ranges to basically determine, so from what was presented to us, we can actually assume that at the center is the robot or the human. And that's actually how we assume the position of the human or the robot. Yeah.
Okay. My follow-up question was, did you think about differences maybe between if the session was run by a human or a robot in the data? Like, was there maybe a systematic difference in the data?
No, we actually made no distinction in this case, but obviously it would be something that could be further investigated. Okay. Well, one of our biggest challenges actually was to actually understand what the data set is. And we spent actually the first day and a bit of the second day just trying to piece together this and to actually make something of it, and that was a big challenge for us, and that's why we actually didn't have much time to do much of the pre-processing or actually do something with machine learning that has a meaningful result. Maybe I can put it like this. Yeah.
Mm-hmm.
Don't worry, it's just very interesting.
Any further question from the jury? Then, very good, thanks. That was a very complex challenge, so very well done to all of you. Good, then the next one. Next team is called Post, and guess what? They are addressing the challenge provided by PostFinance. I would like to call on stage Robin, Nemec, Sabine, Elomari, Dorian, Voigli, Josep, Teklogiorish. I hope I pronounce it correctly. But yeah, you can correct me. It didn't make it. Okay, good. So the challenge was presented by Daniel Coder, who's also part of the jury, and Sabine and Dorian. Sabine only. Who is going to present?
Me and Dorian.
Okay, perfect. Then the stage is yours.
Thank you.
And the point is yours. And in the meantime, I open your. You can just take your. I don't see your.
Should be. Can you refresh it, maybe?
Yeah.
Refresh it. And we notice
Oh wow.
in the wrong section. That one, the last one, almost.
Challenge.
Yes, perfect. Yeah, without is fine. Good, so 10 minutes and then 5-minute question.
Perfect, thank you very much. So welcome everybody again. So thank you that you listened to our presentation. So we accepted the challenge of PostFinance, and to explain it a little bit in detail, the problem was basically that they have, when they have applications, the PostFinance, like from customers, they receive a lot of credit card applications. So basically, all of it is at the moment still on paper-based form. So the problem is basically that they scan it, the people, the customers, basically scan it and send it to them, or they send it by post and then they have to scan it in their system. And the data is as well not always that readable. So basically the challenge was there also to find something that you can adapt machine learning, that you can read that data more easily. But we find even a better solution. I mean, you don't need to start directly with machine learning. You can just start by improving the process, by an intelligent business process, and create a foundation for future machine learning or basically existing machine learning from PostFinance itself at the moment. So now Robin will explain a bit more about the process they have at the moment and what we did.
Thank you. So, as Dorian already mentioned, our goal was, since we don't have really a knowledge of technical background to tackle this challenge right up front, let's say it like that, and we more came from a business side, so we tried the approach to change the whole process a bit. Well, not the whole, as it's basically a very simple change. So basically what we did instead of, yeah, the pointer would be, thank you. How does it work? Oh, nice. Well, basically our idea was, since PostFinance already has a finance app, which is of course a secure platform as it is enough to make money exchanges in larger sums, why not use it also to sign digital contracts? So basically the validation check still of course
isn't 100% done by KI or by MI. It's also, as we learned, is also partially made manual. So manual labor is still there. So human eyes are still needed for that part. But as the applicant gets further, we would suggest to PostFinance, why not use the app they already have to make digital signatures? Yeah. So basically, we came up with a name, eCheck. That would be our suggestion, just to get a legal binding signature. Yes.
Thank you very much. So basically, to visualize a little bit more what we actually wanted to improve in that process was basically the people, the customers, already have an e-banking connection to the PostFinance conto, of course. And of course, you just need somewhere to adapt this form that they can access while they are logged in already. So somewhere there. And then you automatically open the PDF, basically the document, the form they have, and then you just fill in all the information needed digitally. So basically there is no more handwritten information, just everything digital. And then the main point we then want to improve is after you send basically the form, you need to double check it because it's a new contract. So, well, double authentication. So basically you get a new pop-up. This is just an example of a pop-up. Get the code on your smartphone and then just dial in the code. And then you have this kind of double authentication and can continue with your new contract in that case.
Yes, I noticed. So we did some calculation on assuming that for the first part that one application takes about 10 minutes to process. So from the start from start to end, that also includes the scanning part, the validation part, and with an estimated payment of one employee, we came to these numbers, like 14,000 hours of work time saved in a year, cost saved of 868,000, and we would saved 7 FTE for this task. So basically, with this signature, you would be more efficient, reduce cost, of course. The clients would also get the credit card faster, as the process is save time. And the process can be used for other services. So if you apply it to other contracts for other products that you want to sell. Any questions?
Thank you. So let's start with the questions. Who would like to start first? Yeah.
I first have a question for understanding. In your process, there's the beginning where the form is filled, and you are involved at the end. And the problem, as I understood it at the beginning, is that the form is filled manually, handwritten, and you have to extract the information. Why do you start with your involvement at the end and not in the beginning and replace the handwriting with an online form?
Yeah, that's a good question. So basically we analyzed the whole procedure, like we went with approach. So, okay, if I want to get a credit card by PostFinance, what is the first thing? Okay, so I went to the credit card page of the PostFinance and I tried to order actually one. And the first thing that happened is, okay, you already need a bank account to even get a credit card from PostFinance. Other banks would handle it maybe differently with okay, do you need actually an account by our bank to get a credit card? But by PostFinance, it's mandatory. So basically, they already have informations by that process, and you also see by the data provided, the applications were already pre-filled out as you ordered a credit card as a customer with your personal. With your ID, etc., and with your addresses, and they already get filled out automatically into the form. So basically, all PostFinance need is the acceptance of the conditions. So a legal binding signature, as the information is already provided by making that account. Yeah.
Any further question? Or remark also? Yeah, Stefan?
Maybe a question on the cost savings. You mentioned the time savings, but what is on the other side? Where do you have more expenses with implementing an IT solution? Did you take into account this aspect as well?
No, unfortunately, we didn't put that into account as we were running a bit short on time for a whole broad analysis of okay, how much is a whole new or implementing a whole new feature into an application. And of course, it would be very interesting to see that comparison between these two price points. Okay, would you actually save money or? But I think, well, it's just an assumption of me. In the end, on the long run, of course, IT system would always be cheaper. Maybe not in the beginning, but as soon as you don't need that much maintenance anymore, or already have an existing IT maintenance structure, and don't have to build up wholly something new, I would assume that saving human resources still would be cheaper in the long run.
Yeah, thanks.
You're welcome.
Good. So I suppose no other question. Then thank you. An applause to Team Post. So that shows that also business guys can attend MAKEathon. Thanks for that. And now we switch to a team that is connected remotely. They give me the sign that they are ready to present. The team name is On Remote, and the two members are Antonio Bozankic and Amir Amitzik. The name of the challenge is Improve Image Identification Model. That was pitched by Berk Engels from the company startup On Remote, and the presenter's name is Antonio. So Antonio, the stage is yours. When they give me the sign, I'm going to tell you that you can start.
Okay, hello everybody. Do you see me and do you see my screen?
Yes, we do see you on one
and
screen.
And my screen?
That's enough, right? That we see it here?
Okay.
Perfect. Then you can start, Antonio. 10 minutes maximum, and then question and answer session.
Perfect. So I welcome everybody of you to my presentation of the MAKEathon 2021 on remote. So before I start to show you how we went through our challenge, I first want to describe what our challenge was, because it was yesterday, and maybe some of you forgot it. So first of all, our challenge is quite simple. Here on the left side, we have a phone where we make videos and stuff like that. And with the phone, we scan objects like gaming controllers, gaming consoles, remote controllers, TVs and stuff like that. And by scanning these things, we make videos, MP4 files. And with these videos, we get here on the right side our machine learning API from Google what the objects are that we scanned. For example, here on the left side, we scanned a remote controller. We scanned it for about 15 seconds. The API says, okay, we've scanned remote controller every time. On second 4, it was a remote controller. On second 6, on second 8, and stuff like that. Our challenge was that the objects we should make a more specific version of what we scanned. For example, here, if we scan this remote controller, okay, there isn't any brand right now on this remote controller, but let's assume this would be a Samsung remote controller. And we want that the customers that scan this remote controller get a more specific version of what the remote controller is, and this would be the difference. For example, here we have a Samsung remote controller, next one we have an Apple remote controller, and stuff like that. So now let's look how we have done that, let's take a look how it is currently done. The AI works like that. We have our application, and the machine learning is on an external service called Google Cloud. And it's really simple. You just have your MP4 file, your video, and you make a curl request to the external API service. Google then sends back a JSON file, and this JSON file is written in what you MP4 objects are in there, which you have sent. Maybe it's a bit complicated to explain, but I can show you right now on the next page. So, for example, I've sent a video which is 10 seconds long. And on that video, MP4 file, it says, okay, from second 0.8 until second 4.4, Google AI saw a remote on second 1.1 until second 4.4, the AI saw and stuff like that. But now we see the external AI is external service. It's hard to manipulate that as Samsung remote control, because it just returns these values that the AI is learned with. But there is a solution how you could implement that, how you could fix that. It's simple. Google Cloud Service right here on the right side has more one detector. This one right here, this JSON that was sent back from the request is an object detector. It means it only sent the object that were scanned. Remote controls, persons, calculator, and stuff like that. But Google Cloud also have detectors like text detectors, brand detectors, and stuff like that. And to fix the solution that we have, to fix the problem that we have, is basically we make two curl requests. We have that one MP4 file, the MP4 file which contains a remote control, and we sent it to the Google Cloud. And one time the Google Cloud responds with the object detector. That one detector says from this to seconds, that is remote control. From that seconds, it's a person and stuff like that. And the second time, it responds as a text detector. And you can join the how do you say time. For example, from 0.8 seconds to 4.4 seconds, we had remote control. And now, when we go with the text detector, we could say from 0.8 seconds to 4.4 seconds, we have how do we call it? We have the text Samsung. And so we can connect these two in programming language. Concat these two strings which are given back, and then just show it on the application what is given back. Yeah. And we also said we were just a two-man team. two-man team. There were also some other solutions that we hadn't enough time to went through it. There is Microsoft Azure. This solution is you put your video stuff in, and it also can return stuff with curl commands. And also a good solution is Amazon recognition. We've just read a bit about Amazon recognition, but the difference between Amazon and Google is it just returns one big JSON file, not like the Google JSON file. And this JSON file from Amazon says, okay, you have the description, object, remote control, text, blah blah blah, text, blah blah blah, Sony and stuff like that. So you have a big JSON which is really much more big and has more information in it. So that was everything. From our presentation. I hope I did this quickly and didn't overdo the time. Are there any questions?
Great, Antonio. Thank you very much. So now, any question from our jury? Yes.
Hello?
Yes. Do you hear me?
Yeah, I hear you.
Yes. The question is arriving.
Okay. That's good.
Okay, I did not get this with the text. So you have the object and the text as the JSON file that you received from the Google Cloud. But where does the text come from? At least from the image that you showed, you mentioned yourself that there was no text on the control. So how do you get the text?
It's just this control was a bad example. We assume that we have a Samsung controller. Is it okay for you? And it's just, we sent this MP4 file to the Google Cloud Service, and it gives you the object and the text that are written on the, on the video that we have scanned. And yeah, that's how we get the text. But if there is no text, that's sure, like this remote control, there wouldn't be any text, but you would have to make a good code logic, for example, if there is no text arriving, then put no label, just put remote control. Is that clear?
Yes, I understood it. And if you do not have text, or let's say in general, you get also the JSON file with the object, do you use this object to recognize the remote control by comparing it to other images, for example?
No, I didn't understand the question. We don't get objects, we just get JSONs, and the objects are written in the JSON, like here, as a description. Or maybe I understood the question wrong.
I think I have the exact same question, but to maybe rephrase. So you've got an entire database of pictures of remote controls. Can you think of a way to maybe make this like a different method one could implement to utilize this huge data set to classify the ones that don't have text, for example?
Yes.
Like prompting a user input, or, I mean, is there a method one could use then to?
You mean that a method where we had a user input, so we can, the user types in, okay, this is a Samsung control, and the AI learns, okay, that one with no text is Samsung.
Yeah,
you mean
for
that?
example, yeah, because you've got like hundreds of thousands of images Google, probably at some point.
Yeah, yeah.
Right?
From Google, I didn't read that about Google. This was a Google solution I read about that, but I think in Microsoft Azure, it's like that. You can put your, you can put your data in the Azure Container Cloud Database. Yeah, and then you say, you can mark the controllers and say, hey, these remote controllers are Samsung remote controllers, for example. In Microsoft Azure, it's a bit different. You're a bit more freely.
And another question?
Yes.
Yeah, I was wondering, very, very simple question for basic understanding. While you're recording the video, you could also turn around this remote control, and then maybe there's text on the backside, or?
Yeah, this would be also possible
Okay.
because you just sent a video, and Jason, I just talk it now from the Google API service. Then maybe this was the front side from 0 to 4 seconds, and the back side would be from 4 to 8 seconds. And then on the back side, you would have Samsung control. It's then difficult to join these times and stuff like that, but this would be a code logic which you had to implement.
I mean, so it would also be possible to have multiple pieces of text being returned by the Google service.
Yeah, this is really this is possible. For example, you have also multiple objects which are returned from Google. When we look here, we have a video that is 8 seconds long, and maybe a person walks by and the Google Cloud Service detects a person, or maybe a car drives by through the window, or a calculator is on the table, and the Cloud Service detects also these objects on the table or outside and stuff like that.
Yeah,
so
if I got the discussion right before, you could also, or you've thought about also building, let's say, or an actual classifier that takes as an input what the Google service returns, and then actually learns to predict which exact remote control could be described by all of this information. Is that correct, or?
You mean it's like we once said about Microsoft Azure, that we put some remote controls and say, okay, this remote control is the Samsung remote control, so that I also learn the machine. Do you mean that?
Not from the picture, if that is what you meant, but from all the information, not only the type of object, but also the text and maybe other stuff that the Google service can return. And if there are multiple pieces of text or multiple objects, take everything together and throw that at some model that can maybe learn to say what it is finally, what exact remote control or whatever.
Okay, I know what you mean, but this one wouldn't offer Google Cloud, like I said, because Google Cloud is scanning everything. It's really saying every object that is on the video. It's scanning everything and every text that is on the video. And you have connect these two stuffs by yourself, because you can't do the machine learning on the external cloud service, Google Cloud Service. In Microsoft Azure, it's a bit different because
I was thinking you do it yourself afterwards. Sorry.
Did I answer your question? I'm not sure. I hope I did.
I think so.
Maybe not. Okay.
Thank you.
That's good.
Good, thank you. Then I have a really very last question. If this remote control is printed on paper, is it recognized as an object or not?
That's a really good question. I haven't tested that.
Because if it's recognized as an object, then I think, the challenge provider will not be that happy, right?
Yeah, I know what you mean. It depends on the external service that you use. We haven't tested that Google Cloud Service. That's enough. But it's also like the face recognition from, how do you say, Apple. They also tested it. If you print a face on the paper, does it recognize that? I would say Google is a big company. I would say they looked that this wouldn't happen, but I don't want to say it for 100% sure, and then I'm wrong.
Okay, super. Thank you, Antonio.
Sorry.
And we move on now. One applause for Antonio.
Thank you.
One question from Florian. What?
Sorry.
Wait, do we still have Antonio?
Can you hear me?
Yeah, I hear you.
Okay, perfect. Shoot it.
Can you hear me as well? Sorry, I'm traveling, as you may hear.
We also hear the train.
More of a remark. Yeah, I have more of a remark than of a question. So it looks like a little bit, if I understand correctly, what you're doing is you're supporting the labeling of the remote controls. So you basically right now you just have the class like is there a remote object, and you try to extract the text and the brand from the image to actually label find the labels for the different
Yeah,
objects.
that's exactly what I've tried. Yeah.
All right, okay. And that's a good idea. And I think an extension could be that you try to automatically label those where you can find by the, let's say, by the brand image and the text, your labels automatically. And then for the other ones, maybe they don't have text or any indicators what brand they are. Those you then present to the users to manually maybe classify that and train another classifier based on the image data for the missing, let's say, the missing labels.
Yeah,
So,
yeah,
thanks.
that's good. But it also depends then which external service you use. Maybe the external service say, maybe there are functions in the external service where you can do stuff like that, and maybe there aren't. In Google Cloud, I
Yes.
didn't found that, but in Azure, it's possible.
Yeah, I think there are special models for brand detection and the text extraction. So you would basically combine multiple models to find as many clues for that may hint towards the brand of the remote from different, let's say, different specialized models. Yeah, but great idea. Thanks a lot.
Okay, thank you very much for your question. Okay, have a nice evening. I think I don't hear you anymore.
Okay, good. Thank you, Florian, for this question. And thanks again, Antonio. So now we move on. It's the time of Ryan Preter. Ryan did the pitch on advanced literature research, is challenge provider as well as maker and presenter. So one applause to Ryan that did the three things in one. And now he would also like to connect his computer, and I heard that it could be that the old system will break. So let's pray. All right, we still have lights, which is a good sign. Well, I mean, black screen is not a bad. There is some inception over there. I think, yes. Okay, I give you just a few seconds. So, but that's yours. You have it. Aha, here it is. Yeah, that's right. Unless it's just simply not. It seems like it's plugged in, right? Yeah. And you were plugged into HDMI? Mm-hmm.
Is this the resolution for this screen?
Right.
Do you also have a resolution for the screen? Is it the second screen? When you, yeah, no, this one. What goes to the projector?
I don't think I can, because otherwise that's this. This is built-in. We found a solution. Ryan is going to, no, you, David, call Ryan. Just give me 1 second. The laptop switched off in the meantime, so we have to wait a few seconds. Would you like to say a funny story in the meantime? Do you have anything? No? Oh, yeah, that's a good idea. All right. Here we are. We found. Oops. What happened now? No. Can I activate the audio from you? The microphone?
Great.
Okay, cool.
Okay, cool. You're ready. And then audio is coming from where? You need to have a microphone. Okay.
Okay. I think we are going through 3 or 4 devices right now, so we'll see how this goes. Thank you very much. Okay, so my challenge was based around knowledge graphs and machine learning and literature, so scholarly literature. Again, the problem, maybe it would help to kind of explain that, is imagine you're writing a thesis, you're writing a research paper. This maybe doesn't apply to some of these people up here. I'm actually doing interviews for one of my class about this project, and what I've come to find out is when you're actually in the industry, you kind of already have this knowledge graph in your head, right? So it's not so new to discover a whole new set of papers. You usually already have them figured out. So what I tried to start with was structuring this and finding a good data set. So it turns out there's quite a few structured knowledge graphs of academic literature out there, but none of them actually help the user discover literature. So they are structured ontologies of academic literature, and that's it. There's a lot of research papers out there that say this would be cool if we had it, but so far I haven't found any tools that do what this does. So the infrastructure. I thought it would be a good opportunity to use Databricks because they're a sponsor, and I've never used them before, so I did that. And this is hosted on Azure, so there's 2 sponsors. I wanted to use On2Text. Unfortunately, I couldn't find a download because it takes like 24 hours to get a download, even though they provided a code, which is very nice. So I used Neo4j, which is another industry leader. And on Databricks, I'm using Python. And I ended up talking to Semantic Scholar via API, who turns out to be kind of the go-to solution for structured academic literature. So the process, basically, we want to, you're always in the circle, right? So you have something, and that's how you get into this process, and then you want to enhance it. So you kind of start at the top here. So that's where you build your resources. So that's where you talk to Semantic Scholar through APIs, things like this. Then you can do some predictions with this data. So graph convolutional networks, text analysis, things like this. And then you need to make a suggestion, and this is where your business logic comes in, because it really comes down to how are you going to put these resources in front of whoever's searching for them. And then finally, the user input. So they actually have to decide what comes next. So they are the ones who are actually doing the search, and at the end of the day, they have to either both read the papers, but we want to suggest something to them, and then they need to actually take that suggestion. So now there's a live demo, and they never work, so we'll see how this goes. Okay. So like I said, I'm using Databricks. I have a few notebooks in here, and these entities you'll see at the top, I'm not going to go through the code in detail, but the entities you see at the top correspond to the entities I was just talking about. Here we're going to start with saved entities. So these are entities which you have selected to be part of your knowledge graph. And what I eventually came up with is there's kind of a saved graph, which is what you've taken in as research, and then there's a search graph, which is the actual data outside of that which you could take into your search graph. So I'm going to click Run. We'll see if this works. So it just queried Semantic Scholar, and maybe just a second. So this is Semantic Scholar, by the way. It's a really nice search resource for academic resources. And when you search for something, it's basically like the other publication databases. So it gives you some cool stuff. It's all sorted in the background, but there's really no benefit to this. I'm not really sure why they built this, because it's kind of just like all the others, but it's really nice for querying. So we just queried that for the resources that we started with. And the resources we started with, I started with 2 of the papers that are from the teachers here. So maybe you'll see something you recognize. And now we're going to go to Neo4j. So Neo4j is a graph database, and that's used to store our results in a graph format. And they have what's called Neo4j Bloom, which is a visualization software. So I'm going to connect, and I'm going to add my categories. So these categories I just created in the last step. So we have author, citation, field, paper, reference, and saved. Saved, again, is what I mentioned you took into your saved network. And then we can start querying. So for example, if we want to look at references, so here is the visualization of the graph. So there's 2 papers. Visualizations of, let's see, there's a delay here, sorry. Visualizations of patterns something, I don't know the title, sorry. But there's some authors here present. Pulled in the abstract, citation count, reference count, year, things like this. Likewise, there's also this paper, towards an assistive and pattern learning driven modeling process approach. So what are they surrounded by? Those are what are called saved nodes. You'll see them here. They are surrounded by references, and these references have IDs so far, so they have not been populated. So these are surrounding citations and references, so coming in and going out of the papers, but we haven't dug deeper into them yet because it's computationally tough, and we don't know where the user wants to go yet. But what we do, this goes back into the circle, right? So we just technically enhanced our own results, and now we are going to change this. We maybe want to enhance the references. So you put this in here, and then you run it again. And this is actually the same exact code. So now we're just enhancing those nodes outside of there because we want to use these references for machine learning. So this takes a few seconds. Yeah, thank you to the MAKEathon, by the way. I'm just going to say that while we're waiting, because there are quite a few references that point to these papers. Yeah, and it should be done now. Yeah. So now, pay attention to these hash codes you'll see. These are the semantic scholar hashes. I'm going to refresh the database, and you hopefully should see them turn into titles. But first I have to tell it to do that. There it goes. Yeah, so now all of the references have data associated with them. So for example, you can see this one is referenced, and now the reference has data inside of it. So what can we do with this? We can then go to our third step, which is to predict, and we can run this. And unfortunately, due to time restraints, Frieder, I left you a nice little note here to please not look because they are just random values. So there, I didn't get around to graph machine learning. There's the graph convolutional net, which is, there's a paper published a few years ago about this. And there's a few libraries which I can use. But yeah, just time restraints didn't get there. But what we'll see now is I refresh this again. Then you'll now see a prediction value on these resources. So this prediction value could be categorized. It could be a number, anything you want, but this goes into the business logic. So how do you actually determine what resource comes next? So now we have a prediction value, and we want to actually suggest something. So then we're going to run this notebook, and this takes our prediction values and actually takes the top ones. This goes into the business logic. So how do you, given prediction values across resources, how many resources do you actually suggest to the user? Which ones do you suggest? How often do you do it? So now, if we zoom out a little bit, and I need to add the tag we just created, which is suggestion. So you'll see here, these are suggestions. So based on our node, now our software tells us, okay, we suggest you read these papers based on a set of facts. And then what do you do from there? You can go back to step number 1, and you can take your suggestions, and you can enhance those. And now, when you refresh the database, and then you requery for references, hopefully, so now it's found the references of those references. So now you're in a loop, and now it's really up to UI. So I know I got a little technical there with the Databricks notebook, but this is actually just the back end to a UI which doesn't exist yet, right? So you can imagine a UI where someone goes, they give papers, possibly authors. Oh, that's something also maybe I can demo real quick, is if you want to look at, what's the relationship called? Has author, for example. So here are the authors with those papers. You can also look at which field they are in. So this gets into keyword search, so you could actually combine keyword search and graph-based search. And so, for example, field here is pink, so you can see there's a lot of computer science here. There's also business out to the side. So yeah, using, unfortunately, like I mentioned, I would like to do more machine learning, but what I eventually kind of came to the conclusion of is there's a lot of business decisions you actually need to make first, because you can't just go in and say, okay, yeah, based on the abstract, we're going to suggest something, because there's actually a lot more data here than just the abstract. Yeah, so surprised that actually worked. Yeah, so what did I learn? I learned Databricks, super cool. Neo4j, also super cool. I've never used that before. Highly suggest it. Semantic Scholar, I've never used that before. There's a different platform called ORKG, and that's based around research from, what's their name? Right here, Arthur Brack, Soren Auer. They are based in Hamburg, and they are very much onto this topic. And this is the paper, by the way. And then there's also the machine learning side. I was reading this paper, Semi-Supervised Classification with Graph Computational Networks, Convolutional Networks. Those people are based in Amsterdam. Very interesting stuff going on there. I also learned about Databricks init scripts because, yeah, got a little deep into there. And then the major types of machine learning with graph-based networks, which, yeah, you get into this semi-structured stuff. So thank you very much. Oh, by the way, sorry, future. So Databricks has this cool thing called graph frames, which is, yeah, it's kind of a structured, please tell me if I get this wrong, but it's kind of a relational database mapping to graphs. So you can actually use Neo4j or onto text, pull it into Databricks, and then keep it in kind of a graph frame, so then you can use it as a graph. Onto text, I unfortunately couldn't find the download, so someone please help me with that if you can find it. Graph Analytics, Neo4j has what's called Maze Runner, and they're basically it's a library just for machine learning and graph networks on Neo4j. And then monetization, I could go into this, but I'm actually taking a class on that right now with this guy over here, so I'll probably get to that later in the semester. And Akash, which is a really cool tool, decentralized cloud. Google it if you get the chance. Cool. Thank you very much.
Thank you. Thanks a lot, Ryan. Any question? Yes, Diego.
Did you sleep last night?
I went to bed about 3:30. So yeah, a little bit.
I thought so.
Frida.
So you said I wasn't meant to look, but just what are your thoughts? So when you say machine learning, I'm assuming kind of you would look at supervised learning, right? So what are your thoughts? What would you try to predict exactly, and where would you get the ground truth from? Would it be
good
feedback
question.
of users, or what?
Good question. Something that there's a lot of things that came to mind about directions, and that's and decision paralysis. But one of the things I think you could do is, so these also include PDF links. The Semantic Scholar does. So you could actually pull down the PDFs automatically, scrape them for text, and then you could actually automatically determine keywords to then search further. So you could go in keyword search direction. But as far as supervised learning, that was something I crossed out a couple of those methodologies up there for machine learning on graphs, because node classification I don't see as very applicable here because you already have, it's an ontology, you already have the types, but I could be.
I mean, you made some of them dark green and said they are suggested. So that's your prediction, isn't it?
Yes. Sorry, I was talking about classification as far as sometimes in a graph you don't know, you see a node, but you don't know what it is, and then trying to classify what that is. But here we actually know what all the nodes are, so we're building them ourselves. So yeah, it seems like everything's more towards regression analysis. Yeah, but there's a lot of text analysis to be done. And yeah, you get also into like distances between features, but again, that's also like, what is a good number of citations and how should we actually convert that into, you know. So what I wanted to do, and maybe this goes back to Databricks, is they have these jobs, right? And you can run these jobs nightly. And what I think would be really cool is if you found these kind of keywords that are really well known and really well established. So that's your ground truth, right? So everybody, you can take a topic in academia that's very well focused, and you can put this in, and then based on the core papers, you can use those as your ground truth, and then use the surrounding nodes as your test. So given my core, can I actually, so you can test based on the connections there.
Okay, thanks.
Yeah.
Any further question?
Yeah.
This brings me closer to my other keyword. You think, okay, yeah, but I want to find this new keyword, this other research topic that this is about, and then you can like visualize it in a way. Okay, this brings me closer. That's what I want. But sometimes you don't have enough of the topic. You want to find something new, so you want to move away again from this keyword and move in another direction. And in the end, you want to make the loop and get back to this cluster, and then you really know, okay, I think I've found it all, or I've seen it all. This is the core topic. I'm sure this keyword that I found now, for example, as in my presentation, probably real-time collaborative filtering would be a very good keyword to my challenge. And now, after some analysis, I know, yeah, this is the right one, I'm sure, because I've read a lot of papers and I like came back to it. And then you're like sure that you got it. So maybe without doing all the magic, let the user decide, and then maybe decision tree, I don't know, and get more user input.
Yeah, good question. I was thinking about three things while you're saying that. One is that you were talking with your hands as a graph. So I think natively people kind of think this way, right? And we've been doing keyword searches now for dozens of years. So yeah, if you want to do a keyword search, you can, that's already done, right? So there's still a problem though. And I've verified this. I've done interviews with multiple people, so this is a verified problem. The second thing is that with keyword search, I think often you end up moving older instead of newer because keywords grow on each other. So for example, my thesis is on water data availability, so sustainability water data. And there's this old term called virtual water, and that was in 2002. And then in 2012 came the term water footprinting. And now those terms are kind of interlinked, but nobody uses virtual water anymore. So if I started searching for virtual water, which I did, I would have just gone to older and older studies. So this brings my third point, which is I think in science you have to stand on the shoulders of giants. And in that term, I think you need to stand on studies. You need to stand on something that actually exists. So that's why I'm not going to demonstrate it. I don't want to switch screens again and break the system. But there are keywords integrated in here. You saw computer science. Of course, you could integrate other nodes of those types. But I think it's important to actually look at the studies that are around that. Yeah. Does that answer your question?
Thank you. Any other question?
Yeah.
Stefan, the last one.
Is there any way to parameterize the different maybe weighting factors of different keywords or recent publications or something like that?
Yeah, definitely. That was something I was a little disappointed in, this Neo4j tool. So this is their visualization tool called Bloom, and it doesn't currently on the web tool doesn't allow you to assign sizes of nodes and distances of nodes. Although on the desktop version you can do that. And that's something I really wanted to do. I didn't have so much time. But yeah, of course, so that prediction value, I really wanted to use that as the distances, the edge length, right? And then the node size you can turn into number of citations or number of connections in the graph, which is actually technically different. Because the cool thing about incorporating other types of data, such as authors or keywords, for example, is that the number of connections to a node is now different from the number of citations. Because what I've noticed in academia is we're always focused on number of citations. And that's a pretty good metric, but it's not everything. And so with this approach, you can actually start to incorporate everything. And then the total number of connections is much more helpful.
Yeah, very interesting. Yeah, thanks.
Great. Thanks a lot, Ryan. Another big applause for Ryan. Thank you. You can leave this here. So now we have the last two. Acti team. I would like to call on stage Aluigbo, Kingsley, Obasi Emmanuel, Schumacher Damian, Morgan Fabian. So the challenge address was running a question machine from Dario Trovatelli, and the presenters are Oligbo, Obasi, Schumacher, Morgan. Who would like to start? That's the mic for you. In the meantime, I'm fast. So you're set, and good luck, guys.
Thank you very much. Hello, everyone. So this is the Octet team, and we had a small presentation for you. So if time is money, we want to spend a bit of it on you all. So here's just a task for you. When I say MAKEathon, I want you all to say we shape AI. Are you ready? MAKEathon.
We shape AI.
Thank you. So now, one pace higher. MAKEathon. We
shape AI.
Thank you. So let's get to work.
Yeah. Thank you, Emmanuel, and welcome to our short presentation about the running equation machine. What is the challenge about? The challenge is that we have, or it's developed an AI system which is capable of predicting time from one point to the other point with the given data. That means if we have, for example, we want to go up the mountain and we have the path between A and B, we want to, like, as accuracy as possible to get the data from point A to B. So because you're going up and down, we need to have the different parameters, and that's why we want to go further with it.
Okay, thank you, Damian. So, in short notes, we had to work with lots of data from Garmin wristwatch, and one thing we picked from the exercise was data had a culture. So the first things we tried to do was we needed to clean the data, which was a new context for us. So we tried manually until we figured out that there were simpler ways to clean data, which was a big deal when I was hearing about it. And then we successfully cleaned the data to the point where we had the right attributes we wanted to work with. So we used Vector. We were not able to work with the GraphDB because of the scope and the time. So we used Vector, and with Vector, we were able to feed in the data sets and created the model. And with this model, we used it to test the rest of our data to see the level of proximity or data we're going to, or result we're going to get to help us identify, okay, so at what point can we predict the distance between these 2 points? Why are we trying to do this? First of all, we already know that there are lots of devices out there that can calculate your movement, but we needed an algorithm that can tell if you're going to up to an altitude. So it's able to calculate this altitude and also calculates when you're going down the slope as well. And give you an approximate or a prediction that, okay, according to these certain conditions, this is what, this is how much time it's going to take you to get from point A to point B. And we did that we trained our data algorithm with the Vector, and then give it data sets to also work with. And my colleague will tell us how our results played out. Thank you.
Thank you, Emmanuel. As we can see here, we have, like Emmanuel really said, we use linear regression model to test our machine. We ran it a couple of times to be able to give us like a correlation coefficient of about 96, 0.96, sorry, which implies that there is a kind of a relationship with between the Y and X axis. For example, this is the machine predicting a runner or a wanderer walking in a mountainous terrain, like going through a mountain. It can be able to like indicate when you reach the maximum altitude and as well when you descend to the minimum altitude. Here, we were also able to test the machine. Although we tested this a couple of times, we ran it a couple of times on the Vector algorithm machine, which now, if you see here, we can see that it predicted actually that it would take about 200, or sorry, almost 80 seconds to walk a distance of 200 meters. Right. So, and when we look also here, we can see that we were able to get like a relative error of about between 16 to 20%. We were able to bring it down from 90% or so, between 70 to 90% with constant training of the machine. So it was able to give us this relative error percentage. So Damian would now explain to you the implications of what we have just done.
So now the goal with this data is in the future to implement it in the Garmin watch. And we looked into it, but we didn't have time to implement it. The goal would be through the Garmin IQ platform to run the AI on a computer or smartphone. They have a development platform that you can use. And then you would plan the route that you would run on the smartphone. And then the data, the watch would show you the data and the prediction and would update yourself on the run. So that would be the future to implement the whole solution. And yeah, that's something maybe that will come to this app in the future. So that's about it. And yeah, if anyone has a question, he can answer in. He can ask now.
Thank you, Acti team. Any question?
Let's start.
First question is arriving.
So you said that you predict the time and also depending whether you go up or whether you go down. Where in the data is the information about the slope, where it is going up and where it is going down? So I saw that the distance and I saw the time, but where is the altitude?
Okay, so the altitude was it's an attribute in our data, but we didn't identify it in the graph here. But when you look at the attributes, we had our altitude, we had the speed, we had other variables, and then but the point what we're trying to achieve was when if it's a widget on the wristwatch and you say I want to go from this point to this point, the algorithm is already able to do the whole calculation. We've already trained the data with the attributes in it to say, okay, these are the attributes you're working with. So every time you get this data set, this is the algorithm you're using. So in that algorithm, we already have calculated for altitude, and this altitude also it's in the data itself. Why? Because the wristwatch, when you go up or you come down, it keeps the record of that altitude. Thank you, sir.
Yeah, my question was on the data. So are you considering whole runs at a time? So like you do a run, it's 10 kilometers, and you go up 400 meters and down 200 meters? Or are you considering like the instantaneous time between, so your GPS is maybe polling once per second? Or you know, like what is the format of the data that you're using?
Oh, okay. So usually you want to calculate a point A to point B. But what our algorithm is trying to do is, okay, if I'm going from A to B, what were the conditions in between, which is what you want to understand, right? Okay, great. So when the data we're receiving already is taking each of your coordinates, right? But also, it's also retrieving the altitude where you are, right? And it takes this data and puts in an Excel for you, or in a CSV file. I don't know if that's taking... Right? Okay, so when this data is already captured, it's independent of the user. That's why, like for algorithms like this, they say the more data you have, the more profits. If it was money, right? So if I had Mr. A, I had Mr. B, and Mr. C, they all have their wristwatches. So he already has his own set of data. He has his. So if I'm able to take all of this and train the algorithm, right? So if the next person comes and says, I want to know this distance, it just takes from what it has trained, okay, I've learned this, and then it's able to just give you an estimate to say, yes, we're able to realize that this was the altitude. If there was a weather calculation, it's also able to say, hey, okay, it's also raining at this point, and we have this data in our set. Does that help, sir?
A little.
Oh, okay. Okay, please, you can try the question again. Maybe.
I'll ask you after, maybe.
All right, no problem.
I like to run.
Okay, good. Then I would say a big applause to Acti team. Thanks. And now I understood why your name is Acti team, by the way. Also active on the stage. And so now we are going to call some mentors that helped to implement a challenge. The challenge was provided by Baloise Versicherung. Unfortunately, no makers have decided to implement that, so some mentors have done that. So they will present shortly some results.
All right, do you hear us?
Yes, we do hear you. So the challenge...
Can you see the presentation?
Not yet. I think I...
Do you hear both?
Yes, Michel, I hear you.
Okay, good.
Just one
you don't
second.
See the presentation? I shared it.
So the challenge name was Churn Management in Insurance, and the challenge provider was Klaus Rieger. And now Johannes Stelli and Michael Laubscher will talk a little bit about the progress they've done with it. Thank
Okay,
you,
actually, why was the reason why we concentrated on this? So we had a little bit spare time, and we were really wondering how, maybe we have to go to the next slide, Johannes, how we could use the Azure AutoML. So that we use the Azure AutoML, which provides us many of different algorithms, and with as little effort as possible. So actually the whole point took us about between 2 and 3 hours, and we got already really a cool result out of it about the churn topics. So it was really the goal from us to show the participant how you can use the Microsoft Azure AutoML without really, I would say, deep coding knowledge to get really a good outcome. So I give the word to Johannes. He will explain a little bit about how we started and about the outcome. Thank you, Johannes.
Thank you, Michel. All right, so we had a lot of business questions in this Balwas slide, but we focused mainly on the two, how they could design a churn campaign or design target groups, design personas, and yeah, who are these churners and how could they turn them into not churners? So just to show you shortly what data we received, it was a really simple data sheet with an ID, with number of policies, gender, obviously language, and some other stuff like how old were they when we started the contract, how many years they are, and then most importantly what we focused on, or what was the target on the status. So let me check again. 0 was not churning, but so they were still a customer of Balwas, and 1 was they churned, they go get to another company. So luckily we had one person who had some R knowledge, statistical programming language, and first we analyzed the data a little bit. I think Balwas knows this already, that when there are customers with less time contracts and mainly male, they churn like nearly 50%. We analyzed it further. This is just a little bit statistic over this, and we see, okay, in the younger ages they churn mostly after 2 years, and when we divide that with the gender, we see also that males are a little bit older when they churn than women. All right, so that wasn't machine learning. Luckily, we had another guy in our team who works at Microsoft, a data scientist and ML professional, and he showed us this machine learning studio. I show you that afterwards in a short demo. And we just feed it this Excel I showed you before. We feed it that in this engine, and assigned like a GPU computing power from Microsoft. Then you click start, and the model trains. 1 to 2 hours. It depends on your computing power. And in these 2 hours, over 30 models are tested automatically. So as you see from other teams, maybe you saw they had a huge work to do for testing only 1 model maybe, but this Microsoft service tests over 30 models and then sees which models takes the best accuracy. So our model had accuracy of 85%. So that means if you feed some data in the prediction, you get the 85% chance that the prediction is right. We see that afterwards. Voila. So not only that we get this insight, that prediction model, we also saw what attributes are most impacting this churn. And we saw that the field service, so when a contract were sold in with a field agent, it was very relevant on the positive side, so not churning. But when it's sold in the head office, surprisingly, it was very relevant. You see that here on the negative side. And then you see the rest attributes, maybe the condition, that's the condition where they entry the Baloise contract had a little impact, but the rest was not was not with that influence at all. So that's maybe really interesting for Baloise. And yeah, at the end we had a prediction model. I showed it live now, where we put in 100 of this data which we hadn't trained. So this was new data for the model, and we even had a correction rate of 87%. All right, so a short demo. Let's see to show you how quickly you can do that by yourself. And I really suggest you do that if you have data which you think you could predict something out of it. So that's a tool. You register Azure, and then you first obviously you upload your data. You see that here. You upload it, and you define a little bit the data types very quickly. You say, okay, this is a string, this is an int, and so on. And then after you did that, you already have some statistic over your data, which is, I mean, it's already really difficult to do that so fast in Excel, for example, right? So you see, for example, okay, you have more mails, so maybe the data is not that good. If mails more churn, right, you would need an even distribution here. And then the second step is you create, they call that experiment. And you say, okay, let's experiment, assign a computing power, and this is the part. Yeah, actually, it only took 41 minutes here, and it runs through. And you see now here all the models it ran through. You see that's the first page, that's the second page, and you see, okay, the baddest model had a ratio of 78%, and the best model, actually, you see that here at 85%, what I already mentioned. And voila, you already have your prediction model generated, but furthermore, you can easily click here on endpoint. Voila, endpoint. You create the endpoint, and now you have a publicly accessible endpoint where you can load in some new prediction. And you could imagine you could easily build a UI on top of that. So let me show that. I have a tool here to test this endpoint, Insomnia. And let's see, I sent this request, and I get false return. So with this data, we can predict, okay, she will not churn. But now we can play, and this is actually really interesting to build some marketing strategies, for example. Because if I change here the sales channel on 14, let's see what happens. Oh, this persona would churn. So now you can play with it. All right. Yeah, I think I showed you a little bit of the tool. Maybe Michel, you can add something. But,
yeah, no, that was exactly what we were working on it. And as you see, it took us not really a long time, and we could already got some output, which maybe could be really helpful for a company to see, okay, in which part I have to concentrate. For example, about the field service, you really see that the field service is still important for an insurance. That could be because this guy goes to the home to the customer, takes more time for him to really explain about the insurance instead on online, for example. It could be a reason. I don't know. That is something we have to investigate further. But you really get there some good outcomes to start and to see, okay, where I want to go on and in which direction. Yeah, thank you, Johannes.
Actually, you can imagine the more attributes you add, and this is very easy. If I have the data, the better maybe the model gets.
Great,
Okay.
great,
There
guys. Thanks for
are
this
any
demo.
questions?
And yeah, so is there maybe any remarks for the makers? We can now do the other way around, that the makers make questions to the mentors. Yes, we have a question here, Ryan. Would you like, maybe we need you to speak from the microphone. Yeah. Otherwise, they will not hear you.
Hey, this is really cool. Very nice job. This is yeah, super automated. You had a slide about that showed the age. Do you have the date as well? Because I'm also curious if certain date events, such as maybe Christmas or maybe COVID-19, like affected
No,
affects
we
churn.
actually, yeah, we didn't had any of these data, and since the guy from Ball was not here, we couldn't ask. Yeah, that would be really interesting if such events change the behavior. Yes, that was what I meant with add more attributes, right? Feed it into the model and train again, and yeah, maybe the prediction is even better.
Cool. Yeah, nice job.
Cool. I think now I look at the watch. We are a little bit behind the schedule, surprisingly. So my suggestion is that we go in a break. Like half an hour, we relax, eat, drink, and then we come back, we elect the winner. Before electing the winner, I would like the challenge providers to be here, all of them, all of you, and just say a few keywords about how well you think your teammates, the teams that implemented your challenge, implemented the prototype. Just a few keywords. So, and in the meantime, with the jury, we are going to try to have the hardest job of electing the winner. Good, enjoy the apero. See you in half an hour at 7 o'clock here. All right. Can we start? Good. So welcome back. Sorry for the for waiting quite long. It was a hard decision. Before I elect the winner, I would like to call on stage the challenge providers who could provide some very small statements about how they think the teams implemented the challenges. So please come all of you on stage. And really 30 seconds each so that we can then finish the nice Sunday. Who would like to start? Diego? Yeah?
Just because I'm in the middle?
Yeah, you can.
Okay.
Can be
Well,
there.
yeah, just a few words. I was very impressed with what the team that worked on my challenge produced, and was very happy to see that they were also able to use both Databricks, but also include the knowledge engineering part into the challenge. That was very interesting. I think that's the innovation part. I was also glad to see that some other teams have enjoyed have started to using the platform. If you want to learn more, there is a coupon. Just a reminder, a coupon that is valid for another 2 weeks from now for joining and having like access to all the free courses for Databricks Academy. So you can use that. You will find that in Teams. And yeah, I was very impressed. To be honest, I was very impressed about all the solutions. So yeah, thank you.
Thank you, Diego, from Databricks. Daniel from PostFinance.
Thanks. So to our challenge, so you know when you're a data scientist, the first thing you think of is the technical solution to every problem. So thinking of our problem, I immediately thought of how am I going to straighten these things? What kind of OCR can we use? Whatever. And the business people come in and say, why are you even doing this? This is horrible. Just change the process. And so this was very interesting to talk to the business people and get this kind of different perspective. And you guys are also, let's say, more represented in the post-finance than data scientists as well. So it's maybe more in line with our business. Yeah, and I also learned at this event that young people don't find post-finance cool. So yeah. I'm sorry about that, but you'll be old one day too, so we'll get you then.
Thank you, Daniel. It's the turn of Davide.
So this was a very exciting weekend for me. I have to say, the team that worked on my challenge, they pretty much had to start from scratch. I'm very glad that there were mentors at our disposal, and they could really bring some good tips. So it was a very insightful weekend, and I'm glad they got to learn something.
Is it on now? Amazing group of people. 2 of them are still in school. 2 of them have just started the first semester of the bachelor study, and 1 has just started their master's. I'm a veteran in healthcare, and this is a very complex data set. They stay with us for 2 days to try and do it. So what they've achieved is amazing. It also shows you if you want to combine machine learning with knowledge engineering, it takes time. There's an alchemy. You just cannot do it overnight. And this is what was demonstrated by this. But like you show us, Knut, we have a new group of customers, it's Qantas Flight. Our new group of customers are children with autism who actually can use technology to make a place for themselves in their lives. And this is what motivated this group of young people to come and stay with us for 2 days. Anne, thank you also.
Yeah, thank you. And I would like to thank the team. It really over-exceeded our expectations. I think you met all the criteria and really our challenge for us. And it is amazing how quickly you got to the point, how open you were willing to learn, and what you picked up together, how you pulled as a team. It's really impressive. And you really did it. I just can emphasize for helping children. That was your deepest motivation, and I'm very impressed about this. So thanks a lot.
Thank you very much, Gurmit and Ann. Thanks a lot. It's been a pleasure to have you.
So, thank you, sponsors, for making this event possible. Thank you, Knut. Thank you, Emanuele, and everybody else who contributed. I wanted to take this opportunity because, and especially the team, where initially I felt like, you know, what are we going to do? Everybody came and we just so quickly got together. And that's probably the FI&V effect, that people just quickly came together. And what we did in 2 days, and which is why I love MAKEathon, is what I would have done outside in 2 weeks. So that's the impact of MAKEathon. And I'm taking an impressive learning, what works, what doesn't work, and what's the next thing to do like. So thank you everyone for making this possible, and thanks to the team.
Great, thank you very much. Thanks a lot, Roy. The online, yes. We have Angelica. I'm going to connect her. Shall I step in? Okay. Hi, Angelica, do you hear us? Okay, I just step in here, right? So I think it should work. Angelica, can you speak? No, the audio. Okay, we cannot hear you. We have some technical issues. Can you try again? No, we cannot hear you. So, let me see. Test one. Shall we skip it? Okay, we skip it at the moment and then we will see, we will try later in case. It's getting late, so on the one hand it increases the suspense, on the other hand I think everyone would like to go home at some point, right? So, it's been a quite difficult decision. I think we have also some music in the background that we can start playing. So the three criteria that we have taken into account was relevant to the select challenge, how innovative it is, the prototype that you have developed, and to which extent the make, so machine learning and knowledge engineering, was implemented and considered in this prototype. And then we also did consider some additional factors that for the first time led us to create on the fly a new award. And also for the first time in the history of MAKEathon, okay, the second time, but we are going to have two winners. We couldn't decide between the two. As I said, there was like a long discussion. So both of them got the highest score. And so I would like to, or it's my honor to call on stage one of the two winners, Ryan Prater. So Ryan, congratulations. Congratulations on the way you have implemented the prototype. You fulfilled all the criteria. We were impressed about what you have done within such a short period of time. We would have appreciated to see also a team around you, but yeah, no, it's, you tried your best. So, thanks. Stay here. You can stay, you can share the podium together with the other team. The other team is Databricks. So Databricks, congratulations. We have Vittorio Rinaldi, Samin Sibi, Etienne Fry, Ricard Neff, Yaman Ibrahim, and Thibaut Kegegus. So, congrats guys, Thibaut. Then we have Ibrahim, Ricard, Etienne is not here yet, right? He left. Maybe some of you can give it to him. Etienne, who is closer? Okay, I'll keep it. I'll give it to him. Then Vittorio is not here, I suppose, but Sami is here. Yeah? Cool. Then, congrats again. So we really appreciated the hard work you have put in. It was very complex task, what you had from this big data, and really a realistic challenge that was provided by Diego from Databricks. So yeah, you were one of the last teams who survived yesterday night. I saw you and tried entering the room, coached at around 11:30 more or less, and still really much into the topic and the challenge. So congrats again. So what are you going to receive besides the glory and these beautiful papers is also some Raspberry Pi that is provided by PostFinance. So Daniel is going to hand them over to you. And then in addition to it, if you look back, you're going to see the voucher that you get. It's a digital voucher. We want to be also sustainable, so we decided not to print that. Now you're going to get 6 months of incubation of Impact Club FHNW for each member in case you would like to open your own startup. If this is not in your desire, then you can get 20 hours coaching as a service from the experts, the pool of experts that are inside our Impact Club network. And then finally, each of you can get an attendance of one of the modules in the study programs, Business Information Systems. So if you are not student yet, this is a good opportunity to select. The only constraint is that credits cannot be issued, but you're going to learn a lot and have fun at the same time, similar to the MAKEathon. Good, so congrats again. And now, yes, I would like to announce let me go back to this visual. And I would like to have again this music. The previous one was, I liked it most.
Music.
The music, yes. Please, cannot start otherwise. We have to have the momentum now, because it was a critical decision. I mean, we really thought like, come on, we should kind of also expand this criteria, and we were really deeply touched by this initiative, and we really thought that this is a great cause that was brought for the first time at the stage of MAKEathon, and we wanted to award, to reward this challenge, this topic. So, and they did also a great job. It was super complex, this challenge, and according to not only the jury members but also other mentors. So the team winning the Societal Inclusion Award goes to Dreams. So please join me at the stage, Dreams. Come and fetch your well-deserved certificate. Let's keep Dream On all together to create a better world. Thanks a lot for your effort. So I think you can just yes, you can mix it later on. This and then Dream On. Please join me on the stage. So nice to see you all here. A big applause again. And so for you guys, again, PostFinance has decided to provide vouchers, Digitech vouchers for you. So thank you also to PostFinance. Great job. And yes, so now what else? You're going to enjoy these vouchers. We hope that you had all fun. We would like to say also to Gurmeet and Ann, they were the challenge providers, that we would like to support this cause further. So there is the commitment from the Intelligent Information System Research Group to help you out in bringing this cause forward, this project forward. And now what else? Yes. Now everyone is going to get a digital badge. Let me show you this digital badge. Here we are. Yes, how beautiful it is. So that's a digital badge that every participant will receive because of the effort. So it is worth 1 credit, 1 ECTS. And so, yeah, enjoy your digital badge. This will be sent directly to you via email. And you can share it. You can use your social media, favorite channel, and then talk good about us if you like this event. And spread the message that this event is not only about, only targeting highly techy people, but it's like really we include everyone, because we believe that the power is in the diversity. We have to be all together, collaborate together to create user-centric, sustainable and innovative solutions to create, at the end, ultimately a better world. So with this, I would like to thank you and send you back to the chairs, because the closing ceremony, I would like to have Andreas, Martin, Andreas would like to tell you something about the relevance of this MAKEathon in the society, especially in the northwestern Switzerland.
Yeah, thank you very much. What a weekend, I would say. So you really rocked the weekend. Hopefully you can survive the next week. So really fantastic, absolutely great challenges and problems you solved. That's really fantastic. And that means a challenge done, a next challenge ahead. For the students here, I would like to announce that in 2022 we have already next challenges on the road. For instance, the chatbot challenge, which we do together with IBM and other universities in Switzerland starting from March. I will inform you about this. And maybe 2022 is also a year where we have next MAKEathon. We will see. So spread good news. That would be really fantastic if you could do this. And so you shaped actually AI, right? For the northwestern Switzerland, Olten, Basel, for Switzerland, and I would say for the world. That's really fantastic. Thank you very much for doing this. Und ich möchte noch gerne ein paar Worte auch auf Deutsch noch von mir geben. Dieser Anlass ist ja Teil der Digitaltage der Schweiz und das war eigentlich quasi der Kickoff von einzelnen Events dieses Wochenende. Und schon am Montagmorgen, wenn alle wieder fit sind, ist ein weiteres Event. Es gibt einen Workshop mit Vorträgen ab 5 Uhr abends über KI, Fluch oder Segen. Ich denke mal, ihr könnt da auch was dazu beitragen. Und es ist ein Event für jedermann, jede Frau aus der Region, organisiert von der Digitalregion Olten. Und dann schon am Mittwoch gibt es eine Digitour bei uns an der FHNW, wo es viel zu sehen gibt über interessante Projekte herum um die Digitalisierung. Das war ein wirklich schönes Wochenende. Ich habe viele Erinnerungen, ich nehme da vieles mit, wie ihr gearbeitet habt, die MakerInnen über das Wochenende was auf die Beine gestellt haben um intelligente Systeme zu erarbeiten. Aber ich nehme auch mit, dass wir Jugendliche da hatten am Samstag. Sie sind quasi unsere Zukunft. Die werden dann unser Vermächtnis weitertreiben bezüglich künstlicher Intelligenz. Und da konnten wir einen Impact machen und ich danke den beiden Kolleginnen Maja und Charuta, dass ihr diese Jugendlichen hoffentlich auf den richtigen Weg gebracht habt, dass die Damen und Herren, und es waren viele Damen da, vielleicht mal ein Studium machen im Bereich der künstlichen Intelligenz. Danke vielmals, thank you very much, and many thanks to Emanuele. Lot of organization, non-sleeping nights, and after your PhD you thought you could sleep, but then you have MAKEathon, and maybe MAKEathon 2022, another some weeks of non-sleep, but thank you very much for all your effort.
Thank you. So thanks a lot, Andreas, for the very nice words. And yeah, it was a great weekend. I really enjoyed to feel the vibe, the energy from all of you. I think, mission accomplished. So we started with the objective of learning from AI cutting-edge research approaches, learning from technology, AI-based technology, and learning from complex, not only company challenges, but also societal challenges. So, great job. Thanks a lot. I would like to thank a lot my the research group I'm working with, the Intelligent Information System Research Group, starting from the ladies, Maya, Charuta, that also, that put a lot of effort in it, and even in a short notice, they made it possible to create this MAKEathon youth track. That was a very cool experience and very successful. Then we have, Frieder, Stefan, Knut, David, and and Matteo, Lucia, and who else? And Yolanda. Knut already mentioned, obviously. Yes. So, thanks a lot, and see you next year to the MAKEathon 2022. I hope to see you all again with a lot of energy. I'm going to measure the energy also next year in the morning. So get ready. Now you also know the superhero posture. And thanks a lot to everyone, the sponsor as well, and the partners. Thank you.